Hey guys, so I figured on days we don't have Google Meet, I'll put a 10-15 minute video just covering a couple things, review, things maybe from earlier in the year. So I was kind of I was just looking through my notebook and through the resources they give teachers here associated with the book. And I thought, all right, I'll start just kind of in the beginning here. I know we have, a long time till the test. It's only April 9th. We have till May 18th. But I figured 10 minutes, let's say, every Tuesday, Thursday on something, and I'll title it so that even if you don't watch it now, if you watch it the week before the test, you could watch all these. Let's say I do 10 of these, so that's 100 minutes. Or let's say I do five of these, so there's a little less than an hour, but you could watch 5-10 minute segments here on just some review topics, maybe some terms, some concepts, things you forgot or haven't seen a question on in a while. So I'll record them, like I said, publish them, title them, so that way you could go back and kind of as a good review and study guide, go back and watch these things. All right, and I just have to keep track. Let's see here. How would I do that? All right, so that's a minute. All right. So yeah, I really want to try and keep it to 10 minutes here. So I was flipping through my notes, and the first couple things I came across was the ecology unit, and really focusing on competition and symbiotic relationships. So I'm just going to kind of put these slides back up and then just discuss them a little bit. Um, I just think that's better than nothing, right? So decent review. I think at least just going over something again. Um, so we'll start with symbiotic relationship. So relationship between two species that live in a close association with each other, and there's basically four types here. Mutualism is not on here actually, but mutualism, communalism, or commensalism. Wait a second, where am I here? Oh, that's because I'm not on the right slide. I'm looking at my notes. Sorry, not reading the screen. So there's negative species interactions. Let's come back to that here. I want to do this first here. So if we have mutualism, commensalism, those are the first two that I have in my notes that we first started talking about. So an interaction between two species that increase the chances of survival for reproduction of both species. Um, the coral reef and the algae or the lichens that are within the coral is a good example. They both benefit from that situation. Um, Whereas the algae transfers gases for the coral, I believe. Let me double check that here. Hold on 1 second here. Sorry, I didn't have this ready to roll because it just popped in my head here as I'm doing it. Sorry. Um, yeah, so let's see. Where did I? Lichens composed of one or two fungi and algae, tightly linked to mutualistic. The fungi produce nutrients to the algae, and the algae, that's not the coral reef. Hold on a second here. Where is it? Where is it? Where is it? Sorry, guys. Coral reefs. All right. Yeah. So the algae live within the coral animals. The relationship is critical. The algae die, the coral will die. Many of the lichens that grow on the surface of rocks and trees are made of algae. It doesn't really talk about it too much there. Um, so I'm gonna have to get back to you on that one here. But I know it's to do with the transfer of gases, so that there's oxygen and CO2 exchange there between the algae and the coral reef. You know what? Let's look it up. Mutualism, coral reef. Oops. All right, corals have music. A coral provides the algae with protected environment, compounds they need, and in return, the algae produce oxygen, which help the coral. There you go. I knew it had something to do with gas exchange. So yeah, the algae, when they do photosynthesis, um, um, provide oxygen that help the coral. So there it is, and the coral protects them with the environment there. Good. Okay, back to this. All right, so that's mutualism, commensalism, a relationship between other species. Um, Two species where one benefits, the other one is not harmed or helped. Um, we talked about fish hiding in the coral reef. That was something we talked about. Um, and some birds who perch in trees, right? So the tree is providing a benefit for the birds with the nest, but the tree isn't getting anything out of it, and the tree isn't, so it's not harmed or helped. So that was just another example there of that. Again, just knowing the terms and maybe a couple examples. So parasitism or parasitism, you know what that is. That's like a tick, right? So it's when one negatively impacts the other. So the parasite will survive and it's a benefit for the parasite, but not the host or the other organism that it's living in, right? So ticks would be a good one. Pathogens, right? Pathogens, parasite that cause disease, so a virus or bacteria. Um, let's see, what are some other ones, like a tapeworm? So that one's pretty easy if you guys remember. Predation, interaction where one animal typically kills or consumes another animal, right? This one is kind of disturbing here. The parasitoid, specialized predator that lays eggs inside other organisms referred to as host. But again, so predation is pretty easy to come up with a bunch of examples on that one. And then herbi, uh, herbivore, herbivory. There it is. Got it. An interaction in which an animal consumes a producer. Um, so when herbivores become abundant, they can have dramatic effects on the producers, right? Because that could create overgrazing, let's say. So many species of producers have evolved defenses. So like maybe a prickers. Or some sort of scent they emit, or some other compounds that can be poisonous to them, let's say, or they smell bad. I said that, smell bad, taste bad, right? So the things that would repel the herbivores. So those are the interactions for symbiosis that we need to cover. So mutualism, commensalism, parasitism, or cannot say this word, and then predation, and then back up to competition. So competition is when you have individuals essentially competing, right? They're fighting for the same resources in a limited resource in an area, right? So they have the same realized niche. One species will perform better and drive the other. Typically, that will happen. Maybe the one species has an advantage. Like if we're talking plants, one's taller than the other, right? If they're in fields and one's taller than the other, it's going to get more sunlight, perhaps shade the other one, and then that one will start to dominate. Yep, got that coming up. Competition for a limiting resource. So they this was the experiment with the paramecium. You got the first one here and the second one, and then it says when they mix the two, demonstrate that two species cannot coexist, right? So one of them started to dominate, and the other one did not dominate. Let's see, anything else that I have here? Typically, these resources are food and water or light in the case of plants, but resource partitioning can happen. And they use the example of seed size here. When two species divide a resource based on differences in their behavior or morphology, the evolution of resource partitioning. So, in this case here, over many generations, the two species evolve so that species one doesn't eat seeds of this size anymore, right? So they overlap a little bit here. That's where competition occurs. But then over generations, they start to adapt and change, and now this species only eats this side from here to here, those size seeds, and then species two will eat those sized seeds. You can think of predators. Some predators maybe hunt at night. Some predators hunt during the day. That's another example of resource partitioning. So nocturnal animals. Let's see, what were some of my other examples here? The plant, I'm taller. Let's see. I think that's all I had there written down. So basically, organisms can figure it out. But typically, if it is the exact same set of conditions, one will outperform the other. And that's due to um, some reason that the one organism will outperform. Again, it depends on the conditions, but they could be more genetically favorable to that situation. Like we did that short answer the other day, yesterday, about drought conditions. Some, like the invasive species are out competing the native because they're more of a generalist species. So they don't need as much water. They can adapt, whereas the native needs more water in that case. So competition plays a role in that too. So that was it. How did I do? 10:49. All right, I'm gonna kill it. So that's just a little something that you guys can watch, getting ready for the test. All right, see ya.